All right, first section of the new unit. This is Trigonometric Identities, 7.1 in your books if you want to follow along. Okay, your objectives for this lesson, just two. Well, kind of, it's really two, even though it's split up into three. You will learn and apply the fundamental trigonometric identities. This you've done before, and so most of it you should already have memorized. Some of it, though, might need to be a little bit of a refresher. You will simplify trigonometric expressions. This you've also done before, but not in a whole lot of detail. And finally, you will prove trigonometric identities, and we'll get into that. That's going to be the meat of this lesson. All right, so fundamental trig identities. You should know all these reciprocal identities without having to think about it, but just in case. Cosecant of x equals 1 over sine of x. Secant of x equals 1 over cosine of x. Cotangent of x equals 1 over tangent of x. Tangent of x equals sine of x over cosine of x. And cotangent of x also equals sine of x over cosine of x. All right, your Pythagorean identities. Now this one is the most important one to learn, because from this you can get the rest of these here. Okay, like for example, if I wanted to divide everything by, if you know this one and you say, okay, I'm going to divide everything by cosine squared of x. Look what happens. Sine squared over cosine squared, that becomes tangent, right? Cosine over cosine becomes 1. 1 over cosine, secant. And then you can go through and do the same thing, dividing everything by sine. So that's where we got all those. So if you only remember one, remember this one, and then you can figure out the other two from that. Your even odd identities. This kind of goes back a little bit. If you think about this in a fashion similar to, oh, I don't know. Think about your unit circle. So, for example, if I have a unit circle, okay, positive x, like a negative x, would give me the negative of whatever sine of x would be. So, like, sine of x would take me up here. This is just x. This could be anything. It applies no matter what. Down here, because we're talking about our y values, that'd be a negative x. That'd be a negative degree. Cosine, on the other hand, works a little bit differently. Cosine is the only one that if you have cosine of a negative x, it's going to be the same as cosine of x. But sine and tangent, those are the ones that behave where the negative side you can think about it as migrating out front. Okay. And your cofunction identities. This is kind of like those, if you want to think about it like a wrapping function. All right. So the sine of, for example, pi over 2 minus u would equal the cosine of just whatever u is. And again, this kind of goes back into what we've done the past two units. If you think about, for example, pi over 6 and pi over 3, how your x and your y value, your sine and your cosine value switch places. That's basically what these next ones are saying. Okay? But if you have questions on that, I wouldn't worry as much, I should say, about this stuff as I would about the rest of it. But it still is important to know. But the fact of the matter is you basically know this already. You just didn't know what they were called. All right, so let's look at our first example. We need to simplify. Now, this is simplify. Secant of x minus cosine of x over tangent of x. So the first thing I would do is I would look at the top part and write it in terms of sine or cosine. Now we already have a cosine there, so let's focus on changing that secant of x, and we'll change that to 1 over cosine of x. And then we're going to now, again, focus on the top. And I would separate this and make it so that they have a common denominator. So 1 over cosine of x minus cosine squared of x over cosine of x. Now, since they have a common denominator, we can write this all at once on top. And hopefully you can see why that would be a good thing to do, because then we can say sine squared of x over cosine. So I can simplify the top to this. Now, can't do anything else with the bottom as far as it affecting the numerator the way it is now. So we rewrite tangent in terms of sine and cosine. So we're going to change tangent to, this becomes sine of x over cosine of x, as you see down here. Now remember, when you divide by a fraction, you're actually multiplying by its reciprocal. Now look, that and that cancel out, and this and one of these cancel out. So that's just going to leave you with sine of x. Fairly simple and straightforward, right? Alright, now, proving trigonometric identities. Okay, there's a bunch of different ways that you can do this. One, you can just simplify one or both sides, which is probably going to be what you're going to be doing the most. Sometimes you would add something extra to the expression, such as another trig expression, and I'll show you what that looks like. And this are basically kind of the same thing. Work both sides separately. Sometimes simplifying and working aren't the same thing, but it's just getting them so that they're in terms of the same thing. So like in terms of sine and cosine, if it means getting rid of a tangent, or a cotangent or a cosecant, and changing it so everything is sine and cosine, do that by all means. Alright, so now notice the different wording. This says verify. So basically what we're going to do here is we need to show, you're going to see LHS and RHS a lot. That's just for the sake of organization. LHS stands for left hand side. So RHS obviously stands for right hand side, just so you can keep yourself organized while you're working this out. So my left hand side is this right now. I'm going to go ahead and, if you notice, I simplified cotangent to that and secant to that. Okay, which again, cosines cancel out, so that's going to give me 1 over the sine of x equals the cosecant of x. Now 1 over sine of x, hopefully you realize, well look, I've got a bottom that's cosecant. So I can say, I can change it. This is one way you can do it. 1 over the sine of x divided by 1 over the sine of x, which is the same as multiplying like this, which everything would then cancel and giving you 1, which is equal to what the right hand side. Alternatively, you could have said, well, I know that this is cosecant, that this and this are the same thing, so cosecant divided by cosecant is 1. Either way, you get the same thing. You get 1 on this side, which is equal to the 1 on that side. So that's what you want to do. You want to get both sides equal. Alright, so for this next one, and sorry about this little part here, we've got the cosine of u over 1 minus the sine of u equals the secant of u plus the tangent of u. Alright, so what I did here is with the left hand side, I saw this and how it's set up, and I said, you know what, I've got a Pythagorean identity that looks similar to that, but I need to add something in order for that to happen. So if I multiply by this, and this requires a bit of knowledge, kind of going back to working with polynomials from your Algebra 2 class, and the difference of squares. And you would get, if you multiplied the top and the bottom by this, and here's why we're doing this, because now I have cosine of u times 1 plus the sine of u. I'm going to leave that in there, but on the bottom I'd have 1 minus sine squared of x, which we should know is cosine squared. And that shouldn't be an x, that should be a u. So now I've got cosine of u times 1 plus sine of u over cosine squared of u. This is why we left it separate, because now I can cancel out that and one of these, leaving me with 1 plus sine of u over cosine of u. I'm going to go ahead now and separate that, which this step right here, this, get used to doing that. Get used to going from here to here. Okay, you've got to be able to see that this and this are the same thing, because this is going to help you simplify. Because now I've got 1 over cosine of u and sine over cosine of u, which this simplifies to secant, this simplifies to tangent. So again, that's why that's important, because if you can't get from here to here, you're going to get stuck. And this is because of reciprocal identities. Last but not least, this is going to be working the two sides separately. So for the left-hand side, we've got 1 plus the cosine of a over the cosine of a. We rewrite it again, like in that last step. This part is important right here, going from this transition from this step to this step, because then we can cancel that out and say that that's a 1, because this equals 1, right? And 1 over cosine is secant. And the reason I did that is because I kind of saw this over here. Or you could just kind of stop at 1 over cosine of A plus 1 and see where, the next one takes you. But I can't do anything else with the left-hand side, so now I work on the right-hand side. Tangent squared, so I'm going to go ahead and make that secant squared because I have a Pythagorean identity with this one here. All right, so that becomes secant squared of A minus 1, which I can separate this out. So I'm basically doing the reverse of what I did with the last one. I kind of factored this to this, and then you'll notice I'll be able to cancel that and that out, leaving me with just that. And because the left-hand side and the right-hand side were both equal, this identity is true because of that. Alright, so some keys to success here. If you get stuck, start over, approach it using a different method. Don't just keep trying to use the same thing if you're getting stuck. And then make sure you know all of your identities, especially the reciprocal, which you should know, and Pythagorean, which you should know very soon. You probably don't know this as well, these Pythagorean identities. The other thing is make sure you can go from like 1 plus, I don't know, we'll say tangent of x over cosine. I don't even know what to do with this other than make sure you can see going from something like this to something like this, because that's going to be important. Because if you can't do that, you're going to be in trouble. All right, that's all. Have a good one, guys. Thank you.